This is the 2020 MEXT Special Training College Mathematics paper. Let's begin. Section 1, Number 1. Multiply the first term by root 2 minus 1 and multiply the second term by root 2 plus 1. A plus b times a minus b is a squared minus b squared, so 2 minus 1 on the denominator. This is the answer. Number 2. We have to find the values of 1, 2, and 3. So let 1 be a, 2 b, 3 be c. The least common denominator would be x squared times x plus 1. So a times x and x plus 1, b times x plus 1, and c times x squared. Now, x squared times a plus 1 is equal to x cubed plus x squared, which is the same as the denominator. So from this we know that a plus c is equal to the coefficient of x squared, which is 1, and a plus b, which is the coefficient of x, is 0, and b, which is the constant, is equal to 1. Therefore, a is minus 1 and c is 2. So minus 1, 1, and 2. Number 3. In this question, we need to find the value of x plus 1 over x. First of all, let's modify the left-hand side of this equation. And next, let's rearrange the terms of this quadratic equation. Now, x squared is 5x minus 1, and let's substitute this into x squared here. So the answer to the first part is 5. To answer the second part, we need to perform a little trick called completing the square. Let's add 2 and also subtract 2. Now we can factorize this part. And in the first part, we learned that x plus 1 over x is 5, so let's substitute this value into here. So the answer to the second part is 23. Number 4. In this question, we are given a quadratic equation, and we are also told that the minimum value is minus 1 when x is equal to minus 2. First of all, whenever we are dealing with minimum or maximum values, we need to differentiate the given equation. dy dx 2x plus a. When dy dx is equal to 0, we have a minimum value, and from the question, we also know that y has the minimum value when x is minus 2. So let's substitute this value of x into x here, and let the right hand side be equal to 0. So the value of a is 4. And now, let's substitute this pair of values into the equation to find the value of b. So b is 3. Number 5. In this question, we have an inequality, and we need to find the domain of x. First of all, let's use the change of base rule on this term. The change of base rule states the following. The new base c can be arbitrary, so for the sake of convenience, let's choose 2. 1/2 is 2 to the power of minus 1, so log base 2 of 1/2 is log base 2 of 2 to the power of minus 1, which is equal to minus 1. So let's replace this term with minus log base 2 of x plus 1. And next, let's move this term to the right-hand side. Now, recall the following rule. These two terms can be combined. Log base 2 of x squared minus x minus 2. Now, by definition, log base a of b implies that b is positive. X squared minus x minus 2 is also positive. Let's draw a quick sketch. This graph is positive when x is less than minus 1 or when x is greater than 2. But from log base 2 of x, we know that x must be positive. So we know that x must be greater than 2. When we have an equation or inequality like this, the equation or the inequality can be exponentiated like this. C raised to the power of a is greater than c raised to the power of b. So let's say 2 raised to the power of log base 2 of x is greater than 2 raised to the power of log base 2 of x squared minus x minus 2. Now, log base a of a raised to the power of b is b. So x is greater than x squared minus x minus 2. Now we have a much simpler, more manageable inequality. So let's find the roots using the quadratic formula. So this inequality implies that x is between 1 minus root 3 and 1 plus root 3. But we also know that x must be greater than 2. 1 plus 3 is greater than 2, so x must be between 2 and 1 plus root 3, and this is the answer. Number 6. In this question, we have a regular octagon which has 8 sides. So let's name all the 8 vertices of the octagon. A, B, C, D, E, F, G, H. From A, we cannot draw a diagonal line to B or H. A, C, A, D, A, E, A, F, and A, G. So from A, we can draw 5 diagonal lines. And from B, BD, BE, BF, BG, and BH, 5 diagonal lines. From C, CA, CE, CF, CG, and CH. But AC and CA are one and the same line, so we can draw 4 diagonal lines. Based on this pattern, we can draw 3 from D, 2 from E, 1 from F, 0 from G, and 0 from H. So all we have to do is add these numbers up. 10, 5, 5, so 20. So the answer is 20. Question 7. In this question, we have 2 progressions. One of them is a geometric progression, and the other is an arithmetic progression. In a geometric progression, r remains constant. Therefore, 8 over a is equal to b over 8. In an arithmetic progression, the common difference, d, remains constant. B minus A is equal to minus 8 minus B. From the first equation, we know that B is equal to 64 over A, and let's simplify the second equation. Let's substitute the value of B. A minus 16 and A plus 8. So A is 16 or minus 8. If A is 16, B is 4. If A is minus 8, then B is also minus 8. A and B are not equal, so A must be 16 and B must be 4. Number 8. We have a circle inside an equilateral triangle with the side length of 6, and we need to find the radius r. In order to solve this question, let's focus on the right triangle here. The base is exactly 1/2 of 6, which is 3, and the angle here must be 30, so the remaining angle must be 60 degrees. And in a 30, 60, 90 triangle, the ratio of the three sides is known to be 1 to root 3 to 2. Therefore, r to 3 is 1 to root 3. Therefore, the radius r is root 3. Number 9. In this question, we need to find the value of n, which can be found here. So let's try a few substitutions to see what kind of pattern emerges. So let's assume n is 2, and we're starting with k equals 1. So 1 times 1 plus 1 plus 1 over 2 times 2 plus 1. 1 times 2, 2 times 3, which is 6. So when n is 2, we have 2/3, and when n is 3, 2/3 plus 3 times 3 plus 1, 12, we have 3/4. So I'm sure you can see the pattern now. If we have 7 over 8, then n must be 7, because the numerator is always the same as n. Number 10. We need to find the value of f of x and the constant a. The left-hand side of the equation implies that this is equal to the antiderivative of f of x minus the antiderivative of f of a. When you have an antiderivative, it's impossible to get a constant. For example, let's assume that f of x is x plus 1, then the antiderivative of f of x would be x squared over 2 plus x. So you want to get a constant here. So this means that this part, minus 1 here, came from the antiderivative of f of a. The antiderivative of f of a can become a constant because a itself is a constant, unlike x, which is a variable. So the antiderivative of f of x must be equal to x squared minus 2x, and minus the antiderivative of f of a must be 1. Now, since the antiderivative of f of x is x squared minus 2x, the antiderivative of f of a must be a squared minus 2a. Therefore, minus a squared minus 2 in brackets must be equal to 1. So a is 1. Section 2, number 1. In this question, we have a trapezoid, or trapezium. We need to find cosine ABC. When you know the lengths of all the three sides, you can use the cosine rule. Cosine ABC is 5 squared plus 6 squared minus 4 squared over 2 times 5 times 6. Three over 4. So cosine ABC is 3 over 4. Question 2. We need to find the length of BD. Let's use the triangle BDC here. I forgot to add the length of CD, which is 3. Using a different version of the cosine rule, we can find the length of BD. Cosine BCD. The angle BCD is 180 degrees minus ABC because AB and CD are parallel to each other. So cosine BCD is cosine 180 degrees minus ABC. Cosine 180 degrees of theta is minus cosine theta. Therefore, cosine BCD is minus 3 over 4 from the first question. So, BD is 6 root 2. Number 3. We need to find the area of the triangle ABC. When you know the lengths of all the three sides of a triangle, you can use Heron's formula. Heron's formula states that the area of a triangle is equal to root s times s minus a times s minus b times s minus c, where a, b, and c are the lengths of the three sides of the triangle. So let's first of all determine the value of s. And let's plug in this value into the formula. So the area of triangle ABC, 15 root 7 over 4. Number 4. In number 4, we need to find the value of sine ACD. ACD is this angle here. Now, because AB and CD are parallel, the angle BAC and the angle ACD are equal because they are alternate angles. So sine ACD is equal to sine BAC. There's another formula for finding the area of a triangle. And from the previous question, we already know the area of the triangle here. And we know the lengths of AB and AC, so all we have to do is to plug in these values into the formula to find sine BAC. So the area is 15 root 7 over 4, 1/2 times 5 times 4 times sine BAC. Therefore, sine ACD is 3 root 7 over 8. Number 5. We need to find the ratio of these four triangles. The triangle ABO and the triangle CDO, these two triangles are similar because AB and CD are parallel, which means that the two pairs of alternate angles here and here are equal. When two pairs of corresponding angles are equal, the two triangles are similar. And we are given that the ratio of AB to CD is 5:3, meaning that the ratio of the two triangles are 5 squared to 3 squared. So the ratio of triangle ABO and triangle CDO is 25:9. Next, let's look at the triangle ABO and BCO. Since ABO and CDO are similar, the ratio of AO to CO is 5:3. Therefore, the ratio of these two triangles is 5:3, which is equal to 25:15. Likewise, let's look at the triangles ABO and DAO. Again, because ABO and CDO are similar, BO to OD is 5:3. Therefore, ABO to DAO is also 5:3, which is equal to 25:9. So the answer is 25:15 to 9:9. Number 6. In the final question of this section, we need to find the scalar product or the dot product of vector CD and vector CA. To find the scalar product of two vectors, we need the magnitude of vector A times the magnitude of vector B times cosine theta, where theta is the angle between the two vectors. So the scalar product of vector CD and vector CA is 3 times 4 times cosine ACD. And ACD and BAC are equal because they are alternate angles. So cosine ACD is the same as cosine BAC. So let's find cosine of BAC using the cosine rule. So cosine of BAC is 1/8. And now let's substitute this value. 3 times 4 times 1/8 is 3/2. And this is the final answer. Section 3. In this question, we are looking at two graphs. One of them is a cubic function, and the other is a linear function, and we need to find the coordinates of the points A, B, C, D, and E. So let's first of all try to figure out the roots of the cubic function. First of all, you need to pay attention to the constant at the end. This constant tells us that one of the factors must be 1. So let's try substituting this value into x. So 1 is one of the roots. So x cubed minus 3x squared plus x plus 1 must be divisible by x minus 1. So x squared times x is x cubed. X squared times minus 1 is minus x squared. Minus 3x squared minus x squared is 3 plus 1, which is minus 2x squared. Minus 2x times x minus 2x times minus 1. X minus 2x minus 1 times x minus 1 times minus 1. let's try to factorize this part, which can be factorized using the quadratic formula. So a must be 1 minus root 2, 0, and b must be 1, 0, and c must be 1 plus root 2, 0. Next, let's find the coordinates of point D. Since D is on the y-axis, its x-coordinate must be 0. So let's substitute 0 into the cubic equation, 1. So D is 0, 1. In the question, we are given that the straight line goes through the point 1, 2, and we also know that the straight line goes through D. Given the coordinates of these 2 points, we can find the values of m and b. So let's first of all find the slope. So the slope is 1, and because D is the y-intercept, b must be 1. So the equation of the straight line is y equals x plus 1. To find the coordinates of E, let the cubic function and the linear function be equal to each other, and solve this equation for x. And the x-coordinate of D is 0, so the x-coordinate of E must be 3. So let's substitute this value into the linear equation. So E is 3, 4. And this is the end of this exam paper. If you have any questions, please let me know, and see you next time.